Okay, so now we are on speed time graph, which is a little bit different from distance time graph. So now instead of distance against time, we will have speed against time, and this will tell us different things. And it can be a curve, it can be straight lines, and it can look something like mountains and valleys. In this case, a sharp mountain and valley. Usually for speed time graph, we will actually look for like other things such as acceleration. And actually, you can actually also find the speed behind it as well. So there are many things you can do with speed time graph, distance time graph, etc. Okay, so for this case, the first question is we want to find the acceleration of the object in the first 2 seconds. It's pretty simple. We know that acceleration is actually in fact speed over time. So we just need to find out the speed at 2 seconds, which is in fact just 2, right? 2 cm per second divided by 2 seconds, and the acceleration here would be, I'm sorry, it should be speed at 2, yeah, 2, it just gives you 1 cm per second squared. It should be -2, right? Yeah. Okay, so second squared, right? Yeah, it should be second squared, sorry. Okay, so in this case, it's actually pretty straightforward. Nothing too difficult. I think you have learned this in physics. And to find distance is actually in fact the area under the graph. Okay, something to take note here is if you want to find distance traveled, okay, for like speed time graph, you're actually looking at the area under the graph. And so the area under the graph, we can split it into like 4 segments. So we have a triangle here. Okay, we have a triangle here, a square, this random shape here, and this random shape here. So I'm gonna like just do this. The shape A is actually in the form of a triangle, so that's half times, you can just take the unit length here, half times 2 times 2. Okay, B is actually just 2 times 2. It's a square, right? C is actually made out of 2 things, so you need to add both things. One is the square, 2 times 2, plus the bigger triangle here. Okay, this triangle is half times 2 times 6. And finally, D, which is the larger one, is in fact half times 8 times 4. Okay, you can also just simply put this into your calculator and you'll find your answer, or you want to be like just add all of them together and see how this goes. Sure, go ahead. Okay, anything that works for you, it's fine. Okay, so in this case, we have 16 plus 16, it should be 32 cm. Alright, so to find total distance, or it's in fact for a speed time graph, is actually the area under the graph. So the last one, part 3, is to find the deceleration in the last 4 seconds of the object. Sorry, last 2 seconds of the object. So what we're going to look is actually we're going to look from here all to here. This is the last 2 seconds. We're going to find the deceleration. So how do we actually find the deceleration? In fact, we use the gradient. Okay, so to use the gradient, pretty straightforward. I'm gonna use the gradient of 2 points from which point? From here all the way down here. Okay, so honestly there are only 2 points. I'm gonna use 2 points there. Okay, so I'm gonna use, how do we spell deceleration? Deceleration. Okay, in last 2 seconds. But in fact, the deceleration for the last 2 seconds, right, is in fact would be the same as the deceleration for the last 4 seconds, right? Correct. It should be the same, right? But we don't exactly have to worry much lah. Okay, so in this case, since it's just the gradient, we are going to use something to help us here. I'm going to use 2 points here. So I'm going to use this point, which is 8, 4. So I'm going to use 4 minus 0 over 8 sorry 4 minus 0. Yeah, I'm losing my. Okay, so wait, this is 8 4 and this is 10 0. Yeah, okay, correct. So we're gonna use this and 8 minus 10, and in this case you are gonna get a negative value, but it's actually correct. Okay, you will get a negative 4 over 2. So negative 4 over 2, you will get negative 2 cm per second squared. Okay, technically it's kind of correct, but what you must understand is that technically in this process here, okay, you're actually finding gradient, and when gradient is negative, it tells you that it's going down, which in fact just means it's deceleration. So instead of writing this, okay, I'm just going to write that the gradient in last 2 seconds, okay, is equals to this whole working here. Then I will say that the deceleration is positive 2 cm per second squared. Okay, because the gradient tells us whether is it slowing down or going faster. Okay, that's why it has a negative value. But when you convert it into English, technically it being negative means that it is a deceleration. Okay, so something to take note here for speed time graph. So that will be all for speed time graph.